Oh, there he is. Yeah. Here's my superstars in third hour. Yeah.
Fourth hour.
Fourth hour.
Fourth hour, right.
Don't insult us by calling us third hour.
What's going on there, Siddharth?
He's making some
there he is,
beats.
there he is. I'll be retiring next year. Yeah.
Oh, really?
No, he's kidding. No, no, he's kidding. He's playing.
You think people just sit around, like,
Hey,
Saturday
you
night,
make a
8
bank
o'clock
off the
is the best
videos.
This is what we did yesterday. We looked at electrolysis. First was molten salts. These problems are the very last ones in the chapter. When you get like to number 100 or so, you're going to run into things like, now I know this is a big mess on the board. You'll be asked, okay, here's something that electrolyzes. What happens to the anode and what happens to the cathode? For instance, this is an example of what you'll encounter. What reaction takes place at the cathode and at the anode when each of these is electrolyzed? So if we take a potassium fluoride solution and set up an electrolysis arrangement where you've got 2 electrodes in there, you kick the voltage on, what will happen at the anode, what happens at the cathode? So, we have to determine, all right, what do we have a choice of? At the anode, oxidation has to occur. In potassium fluoride solution, what is in there that could possibly even oxidize? Can potassium ion oxidize?
No.
Remember, these are ions. It's an ionic compound, so the potassium ion, it can't oxidize. Potassium doesn't go any higher than +1. It's +1 right now. So that's not an option. What about the fluoride ion?
Yes.
It could oxidize. It could go from -1 up to 0, where it makes fluorine gas. So one possibility would be, this is not balanced or anything, but we're just going to have it down there. Fluoride ion could oxidize to neutral. Is there anything else in the solution that could oxidize?
Oxygen in water.
In the water, right. So you can have water that oxidizes because the oxygen goes from -2 up to 0. Any other options? There's only 3 things you have a choice of: potassium ions, fluoride ions, and water. So we know that potassium can't. Those are other 2 options. Would you determine what the oxidation potential is of this one and of this one? Now the fluorine's not hard to find. What's the oxidation potential of fluoride changing into fluorine gas? Negative 2.87, right?
Yeah, you said it.
What is the oxidation potential of water changing to oxygen?
It's higher.
That one's a little harder to find. It is higher. You don't have a choice.
like -1.23.
Negative 1.23. Okay, so between these 2 choices, which one is going to then happen at the anode? Yeah, it's going to be water changing into oxygen. So we'll observe oxygen bubbling on one of the terminals. We'll know that one's the anode. All right, so for the cathode, something has to reduce. What can reduce? Can the potassium ion reduce?
Yeah.
Yes, it can go from +1 down to 0. And once again, good luck with that. So K positive going to K. What else can reduce? Can the fluoride ion reduce?
No.
No, the fluoride is a -1. Fluoride doesn't go any lower than -1. The hydrogen, though, in water could reduce. So you could have H2O going to hydrogen. What are the what are the reduction potentials of these 2?
Negative 2.9.
Yeah. The potassium is going to be feeble to try that one. Negative 2.92 volts. And then the water, can you find it? Negative 0.83. So, in this solution, when you run your electrolysis equipment and set it up, you're going to find that at the anode, oxygen is bubbling out. At the cathode, hydrogen is bubbling out. You can say, oh, there's bubbling in both. You can't tell the difference between them. Just from their physical properties, you'd have to try to light them on fire or see how they smell or whatever to figure out which is which. Okay, now I'm going to ask you to do the same exercise. Yes?
Wait, so if it was like a 2 molarity KF solution, we'd use the Nernst equation for...
No.
Oh, you
No. Just use the table values. It's fine.
Okay.
Because you're going to get the same ratios. It's fine. Try this one. What happens at the anode and the cathode when you electrolyze zinc iodide? Solution is the solution of zinc iodide. So you have to determine what could oxidize at the anode, what could reduce at the cathode.
You're actually so stupid. Oh my god, this is why you're so dumb. It is. Yeah. You're just weak. This is why you're stupid. No, you're really not.
You identify who oxidizes and who reduces?
Yeah.
Good. Between iodide oxidizing and water oxidizing, the one that's more positive, in this case, is not the water. It's the iodide ion. So what would we observe at the anode?
Iodide.
Any idea what that would look like?
Purple.
Iodine is kind of a purple color. It's a brown purple color. Yeah. And so yeah, and it's a solid. So your electrode would be coating with this brown purple solid. Yeah. And what about at the cathode? What would you observe at the cathode?
Zinc.
Yeah, you'd get zinc plating itself onto the electrode. Yep. Because this one is more positive than that one. I get a lot of questions about that as people go through the homework. I want to just make sure that I tried to give you a good example to use. Okay. We only have one thing left in the chapter, in this topic, and that is kind of like I just mentioned at the cathode. At the cathode is where you can take a metal ion and get it to reduce onto the electrode, and that is also known as plating. When you plate a metal onto an electrode, you're using electrolysis to you run electrons into it, you have a solution of those ions, you have those ions reduced on and coat the electrode. work could people do that would be involved with plating?
Oh, like gold plating.
Jewelers, yeah, gold plating things. Yep. This is how you would dip the chain, whatever the chain is made of, into a solution that contains gold, and you'd electrolyze it. You'd have gold reduce on it, and that would plate it. Who else? Who else would be concerned with plating?
Car manufacturing.
Cars, any kind of vehicle or equipment. Now, do you know, Girish, what would they plate?
Titanium. Aluminum. It's aluminum alloys.
Okay, now alloys are something different. Alloys is when you melt two liquids and mix two metals and mix them together.
Yeah, you were like firing stuff.
You did well, Girish.
I tried my best.
I know you did.
That's all that matters.
When a car part is made, or any tool or whatever, often it's made of steel. And then they need to paint the car part. Well, before they paint it, they have to add a primer to it. And they don't have people that stand around spray painting the primer on it, or even the paint these days. I think most of the painting done on cars is they'll take the part and they'll dip it. And people that are in the industry, you'll hear them talking about dipping car parts. Well, that's their way of painting it. They'll put it into an electrolytic cell and then kick the voltage on, and that will cause a plating process to happen. So that's the way that cars are coated. Now, do we care how much plating happens on it? Well, yeah, big time. The people who are doing the plating process, they need to be aware of a couple things. Number one, they don't want it to be too thin, or else it probably won't have good corrosion resistance. You know, any stone chip or whatever will knock off some of that and expose the iron to the air, and you'll have rusting. So they don't want to make it too thin. They also don't want to make it too thick, because it'll be cost prohibitive. They'll spend too much money on it. So the amount that plates does matter. Like people that make gold-plated jewelry. The people that make El Cheapo jewelry, they want just enough gold on there to make it look nice before they can sell it. And then after that, they don't care, right? So they would use very little gold. People that want to make decent gold-plated jewelry, they're going to put a thick layer of gold on there. So the amount of plating is a big deal in a lot of industries. So I'm going to just cover this up for a moment. How are we doing for time? Not good. So I'll stop there, and then we'll pick this up when we get back.